Good day everyone, I'm Daisy Jo Salvana and we are the Group C and our report topic for today is about Unified Modeling Language or UML or Activity Diagram. What is UML diagram? UML stands for Unified Modeling Language. It is an industry standard graphical language for specifying, visualizing, constructing and documenting the artifacts of software system. The UML uses mostly graphical notation to express the analysis and design of software projects. The UML represents a collection of best engineering practices that are very helpful in the modeling or large and complex systems. Why UML for modeling? It is mostly used for simplifies the complex process of software design. The UML is very important part of developing object-oriented software and the software development process. The UML helps project teams communicate, explore design, and validate the architectural design of the software. And there are three types of UML, which is structural, behavioral, and interaction. Under the structural is class diagram, component, object, deployment, composite, structure, and package. Under the behavioral is the activity, state machine, and use case. And under the interaction is the communication, sequence, and timing. Activity diagram. Activity diagrams represent the dynamic or behavioral view of a system. Activity diagrams are typically used for business, transaction, or process modeling and modeling the logic captured by a single use case or usage scenario. Activity diagram is used to represent the flow across use cases or to represent flow within a particular use case. UML activity diagrams are the object-oriented equivalent of flowchart and data flow diagrams in function-oriented design approach. An activity diagram contains activities, transitions between activities, decision points, synchronization bars, swim lanes, and any more. Activity diagram also describes how activities are coordinated. Is particularly useful when you know that an operation has to achieve a number of different things and you want to model what the essential dependencies between them before you decide in what order to do them. Records the dependencies between activities, such as which things can happen in parallel and what must be finished before something else can start. It represents the workflow of the process. So, we use activity diagram to illustrate the flow of control in a system and refer to the steps involved in the execution of a use case. We model sequential and current activities using activity diagrams. So we basically depict workflows visually using an activity diagram. An activity diagram focuses on condition of flow and the sequence in which it happens. We describe or depict what causes a particular event using an activity diagram. An activity diagram portrays the control flow from a start point to a finish point, showing the various decision paths that exist while the activity is being executed. We can depict both sequential processing and concurrent processing of activities using an activity diagram. They are used in business and process modeling where their primary use is to depict the dynamic aspect of a system. An activity diagram is very similar to a flowchart. So let us understand if an activity diagrams or a flowcharts are any different. That's all. Thank you.
Alright, good day. This is Antonio Pasco Jr. and I am tasked to discuss the difference between an activity diagram and a flow chart. So yeah, typically, wait, adjust this, my face. So flowcharts are invented earlier than the activity diagrams. Non-programmers they use flowcharts to model workflows. An example is a manufacturer uses a flowchart to explain and illustrate how a particular product is manufactured. So we can call a flowchart a primitive version of an activity diagram. So yeah, it's hard for me to adjust this. So yeah, the flowchart is a primitive version of the activity diagram. So business processes where decisions making is involved is expressed using a flowchart. So programmers use activity diagrams, which is the so-called advanced version of the flowchart, to depict a workflow. So this is for the flowchart. And for the activity diagram, it is used by developers to understand the flow of programs on high level. It is also enables them to figure out constraints and conditions that cause particular events. Note the flowchart converges into being an activity diagram if complex decisions are being made. So more advanced lugar siya ang flowchart. So I mean that the activity diagram. So yeah, a flowchart converges into being an activity diagram if complex decisions are being made. So with that, we need to convey a lot of information with clarity and make sure it is short. So an activity diagram basically helps people on both sides. Example, businessmen and developers to interact and understand systems. So this is the example of here in my left, here in your left view, started with the word start. This is an example of a flowchart. So from start, going to here alarm, and then turn alarm off, then going down. Do you want to get up? If no, reset alarm. This is like how you create a flowchart when you're setting up an alarm. Then go back to sleep, then you hear alarm. But if you're going to get up, yes, get up, then you have to stop the alarm. So that is how the flowchart works. And for the activity diagram, an example here is it started with receiving an order, and then there's filling an order, going to filling an order. Then is it a rush order? So overnight delivery, else a regular delivery. So you have to close the order. On the other part, send an invoice and then receive payment, then close the order. So yeah, if we're going to look at the example, so it clearly stated that the examples show that an activity diagram is more advanced flow than the flow chart. So let's proceed. I'm dancing, my camera is dancing here. So what? Okay, there is a question raised that do we need to use both the diagram and textual documentation? Different individuals have different preference in which they understand something. So if we're going to make an example, some people might prefer a written might prefer a written tutorial with images, while others prefer video lecture. So we generally use both a diagram, and others would prefer a video lecture. So we generally use both diagram and textual documentation to make our system description as clear as possible. So it ended so soon. So basically that was it. The comparison or the difference between the flowchart and the activity diagram. So the next topic would be discussed by my colleague, and the topic would be the activity diagram notations. So the next reporter, there you go.
Activity diagram notations. The first notation of the activity diagram is the initial state. The starting state before an activity takes place is depicted using the initial state. Ang starting state daw is sa wala pa ang usa ka activity nga mahitabo is ginarepresent siya gamit ang initial state. As we have seen, there is a figure of a black filled circle. This black filled circle depicts the initial state of a system, and for objects, this is the state when they are instantiated. A process can have only one initial state unless we are depicting nested activities. So, ang usa ka process is naa lang siya usa ka initial state unless kung atong i-represent ang nested activities. The initial state from the UML activity diagram marks the entry point and the initial activity state. For example, here the initial state is the state of the system before the application is open. The second notation is the action or activity state. An activity represents execution of an action on objects or by objects. And basically, any action or event that takes place is represented using an activity. As we have seen, there is a figure of a rectangle with rounded corners. Gina-represent niya ang activity gamit ang rectangle with rounded corners. For example, consider the previous example of the initial state of opening an application. Example, opening the application is an activity state in the activity diagram. The third notation is the action flow or control flows. Action flows or control flows are also referred to as paths and edges. They are used to show the transition from one activity state to another. As we have seen, there is a figure of a line with an arrowhead, which is mauni ang ginagamit to represent the control flow. An activity state can have multiple incoming and outgoing action flows. If there is a constraint or restriction to be adhered to while making the transition, it is mentioned on the arrow. Consider the example. Here, both the states transit into one final state using action flow symbols. The fourth notation is the decision node and branching. When we need to make a decision before deciding the flow of control, we use or kagamit taog decision node. As we have seen, there is a figure which is the notation for decision node. The outgoing arrows from the decision node can be labeled with conditions or guard expressions. It always includes 2 or more output arrows. There is an example of an activity diagram using decision node. The fifth notation of an activity diagram is guards. A guard refers to a statement written next to a decision node on an arrow, sometimes within square brackets. As we have seen in the figure, the guard is being used next to a decision node. The statement must be true for the control to shift along a particular direction, and guards help us know the constraints or restrictions and conditions which determine the flow of process.
How to draw an activity diagram. First, identify the initial state and the final state. Second, identify the intermediate activities needed to reach the final state from the initial state. Third, identify the condition or constraints which cause the system to change control flow. Fourth, draw the diagram with appropriate notations. Uses of an activity diagram. First, dynamic modeling of the system or a process. Second, illustrate the various steps involved in a UML use case. Third, model software elements like methods, operations, and functions. Fourth, we can use activity diagrams to depict concurrent activities easily. Fifth, show the constraints, condition, and logic behind algorithms. So, mauni siya ang amoang kuan kanang example sa among activity diagram, ang login system. Kanina sa taas, kaniya siya mauni siya ang kuan kanang starting node or initial states. Ginagamit para ma-activate ang software. Ginagamit siya. Tapos kaniya siya muna siya ang action. Nagpapahiwatig ng gesture ng user at ng system. Tapos kani siya muna siya ang decision. Ito'y ginagamit kapag ang software or system nagre-require ng desisyon. So, tapos kaning mga arrow, muna siya ang ginatawag na action flow para malaman ang flow ng interaction between user and the system. Tapos, kaning mao siya ang iyahang terminator or end node. Sa among example, makita naman ninyo ang nagkalaylay nga unsay dagan aning mga kaning arrow, kani sila sa ilang mga dagan ana. So sa first kani user, kung mag-login ka sa system, di ba? Kaning system, di ba, mao ni siya ang user. Gusto ka mag-login sa like Facebook. Kaning system ang system mangayo sa user sa iyahang input ang username o iyahang password. Tapos kung ang system, kaning mga system na dayon ang mag-validate dinhi na dayon siya magkuan. Kaning system na dayon ang mag-validate sa kanang magdesisyon kung tama ang input nga gibutang sa system, di ba? Pero kung ang imong na input na password or username nimo is kanabitang mali, magkuan siya ganing kuan incorrect, so dili siya mo kuan sa try again. Dili siya mag-try again na pug ka. Naka-display naman ang try again. So dili ka mo balik ka didto sa kuan. Dinhi mo balik ka sa kanang action niya nga kuan nimo i-input nimo ang imong correct username o ang imong password. Tas ubalik na po siya dire sa kanang decision. Kaya mo naman ni siya ang decision, ang system dini na siya sa decision maker. Tapos kanang kung sakto na din ang imong kuan, sakto na ang imong pag-input sa imong mga password o sa imong username, mag-validate naman dayon sad niya siya kung sakto. Dini na dayon kung sakto, dini na dayon ka mapaingon sa kanang kuan or makabutang na siya og successfully kanang login. Mag-successful login na ka, mga din siya ang ato ang kanang ending node or terminator.
Fork node is a control node that has one incoming edge and multiple outgoing edges, and is used to split incoming flow into multiple concurrent flows. Fork nodes are introduced to support parallelism activities as compared to UML 1.5 and UML 2.0. Activities forks model unrestricted parallelism. If a guard used in edges outgoing forks are modular should ensure that no downstream joins depend on the arrival of tokens passing through the guarded edge. If that cannot be avoided, the decision node should be introduced to have the guard and shown to the token to the downstream join if the guard fails. So this is the example below. The activity of making coffee can be split into two current activities, and hence we use the fork notation. Join nodes are used to support concurrent activities converging into one for join notations. We have two or more incoming edges and one outgoing edge. Join nodes are introduced to support parallelism in activities. The notation for a join node is a line segment with several activity edges entering it and only one edge leaving it. Join nodes have a join specification, which is Boolean value specification using the names of incoming edges to specify the conditions under which the join will emit a token. The join specification is evaluated whenever a new token is offered on any incoming edge. The evaluation is not interrupted by any tokens offered during the evaluation, nor are concurrent evaluation started when the new tokens are offered during the evaluation. So there's an example. When both activities is a streaming, the melt and adding coffee get completed, we coverage them into one final activity notation. Merge or merge event scenarios arise when activities which are not being executed concurrently have to be merged. We use the merge notation for such scenarios, so we can merge two or more activities into one if the control proceeds into the next activity irrespective of the path chosen. Merge event is defined as the merging of two or more requirements into one requirement and is formally represented as Ri plus Rj plus Rm A. So, figure 2 represents a simple example in which two requirements R1 and R2 are merged into R3. Prior to the merge object, 01 is dependent upon R1 and O2 upon R2. Change event recognition algorithm is described below using pseudocode based upon the operational systematic of the requirement and link depicted. So, this is the example. In the diagram below, we can have the both sides executing and concurrently but the finally merge into one. A number can be both odd and even at the same time. Swim lanes for grouping related activities in one column. Group related activities into one column or one row. Swim lanes can be vertical and horizontal. Are used to add modularity to activity diagram. It is not mandatory to use swim lanes. They usually give more clarity to the activity diagram. It's similar to creating a function in a program. It is not mandatory to do but it is recommended to practice. Swim lane diagram is a type of flowchart that outlines who does not what in a given process. Based on the analogy of lanes in a pool, swim lane diagram places process steps within the horizontal or vertical. Swim lanes of a particular department, work group of employee, thus ensuring clarity and accountability. So, here's are the example. Here, different set of activities are executed based on if the number is odd or even. These activities are grouped into a swim lane. Activity diagram making use of swim lane. Time event. So here's are the example. Let us assume that the processing of an image takes a lot of time, then it can be represented as shown below an activity diagram using time event. So you can see in image input, image processing. Final state or end state, the state which the system reaches when a particular